Lesson 13, Force and Net Force. Now that we have finished the first 12 lessons, which dealt with the basics, we're finally going to start with some physics. Let's take a look at our objectives. Our first objective is to define force and identify the fundamental forces of nature. Next, you want to be able to define and calculate what we mean by net force. You will want to be able to explain the concept of equilibrium, as well as to explain and apply friction as a force that opposes motion. Let's start with our definition. Force is going to be something which is going to show up from now until the very end of the semester, but it has a very basic definition. A force is a push or a pull in a particular direction. It's as easy as that. The unit for force is one that you've seen already, because we've taken a look at a force, weight, and you saw that weight is measured in newtons. That's because it's a force. All forces in the MKS system are measured in newtons. And remember, Newton is abbreviated as a capital letter N. There are 4 forces which are found naturally in our universe. From weakest to strongest, they are gravity, the electromagnetic force, and what we call the weak and strong nuclear forces. Let's take a look at each of these in a little bit more detail. Gravity is a force of mutual attraction between objects, and as I said, it's the weakest of the 4 forces. As a force of mutual attraction, remember, force is a push or a pull. Mutual attraction means that it's going to occur between at least 2 things because it's mutual. And attraction means that they're always going to pull together. So gravity always pulls things together. It doesn't push things apart. The electromagnetic force is a force of attraction or repulsion that arises from an electric or magnetic field. So this is a push or a pull that will pull things together or push things apart because it's attraction or repulsion. And you can see these very easily with magnets, where you can have 2 parts of a magnet pull together or 2 parts of magnets that push each other away from each other. Lastly, we have our strong and weak nuclear forces. We're going to combine them together under one category and just call them nuclear forces. These are the forces that hold atoms together. The weak force, even though it says weak, is not very weak. It's only weaker than the strong force. They named them this way in order to tell the difference between the 2. But the weak force is actually stronger than both the electromagnetic force and gravity. Net force. The word net, when you see it as an adjective here, means what you see. For example, if you have a job, you know that when you get paid, you have your gross pay and your net pay. Your gross pay is what you actually earned, and your net pay is what you take home, what you see. This is what also applies here. The net force says when 2 or more forces act on an object, they react in such a way that it appears as if only one force exists. So even though there's more than one force acting on the object, we only see one force really acting on the object. In order to calculate the net force, usually you require trigonometry. We're only going to work in 2 situations where we won't need this. To determine the net force, we have 2 situations. If the forces act in the same direction, we add them together. If the forces act in the opposite directions, we subtract them. So for example, if your car stalls and you want to get it moving and you go out and push it and you apply 500 newtons of force and it doesn't move. So your friend comes along and he pushes with 1,000 newtons of force, hopefully in the same direction. So you now have 500 newtons and 1,000 newtons both acting in the same direction. We would add them together and get 1,500 newtons. The car experiences really one force of 1,500 newtons acting on it. So it appears to the car as if there's really only one force. Let's take a look at another example. A force of 5 newtons acts to the right and a force of 6 newtons acts to the left. What is the net force? So as usual, we identify what we're looking for, in this case, the net force. So the next thing we need to take a look at are our two forces. We have 5 newtons, which is acting to the right, and 6 newtons, which is acting to the left. So in finding the net force, we need to ask, are the forces going in the same direction or the opposite direction? Since these forces are going in the opposite direction, we would subtract them. 6 newtons minus 5 newtons and get 1 newton. If you need to know the direction of the net force, and you had to subtract, it would always be in the direction of the larger force. In this case, left. So 1 newton left. Now notice that there was no formula for this, but when you do your problem set, I'm going to expect that you are going to show whether you have to add or subtract to get your answer. Going along with the idea of net force is the idea of equilibrium. Equilibrium is when all the forces on an object cancel, or in other words, when the net force equals 0. Right now, you're probably sitting on a chair. Gravity is pulling down on you. The chair is pushing up on you. The force that the chair applies upward is equal to the force of gravity pulling downward. You would subtract the two forces and you would get 0. Another force that we need to take a look at is friction. And friction is going to be important when objects are moving. Friction is a force which opposes motion. As such, it'll always act in the opposite direction of motion. When you are doing problems and it speaks of friction, it will automatically suppose that you know that the friction is acting in the opposite direction of the force that's moving the object. So pay attention to the word friction. Friction means subtraction.